All right, here we go. Write an equation for each line. The lines here are not really colored, so we got to pay attention to the letters. I have line K right there, line M going down here, line R is straight up and down on number 1 of the x-axis, and P is straight horizontal on -6 of the y-axis. Okay? So let's start with the two that we are used to doing here. If it is a line that passes through y and has an angle to it, I am going to stick to the y equals m times x plus b, where m is my slope and b is my y-intercept. I just write int for intercept, meaning where this line crosses y. Okay, so let's pay attention. Let's try line K first, because that one's the most what I call kind of normal on here. Line K is going to be y equals, now we need the slope. Okay, the good thing is slope is consistent anywhere across the line, so I'm going to go ahead and take a look here. It goes up 1, right 1, up 1, right 1. Okay, so slope of 1 over 1, by the way, just equals 1. Okay, so another thing that we want to get used to, though, is I could write that as 1x, but there is no point in writing that 1. Okay, 1x is the same as just x. So I'm going to go ahead with this one and write just x. If you put a 1 on that x, you wouldn't be downgraded for it. It's just not totally proper. Okay, so as we move forward, we don't write the 1s on the variables, because a number or variable times 1 is the same as itself. So what's the point in timesing it by 1? Okay. Now, I'm not done yet. I need the y-intercept, so I see that this line K crosses y at 4. So, plus 4 for its y-intercept. And that one's done. So let's take a look at the next one that seems to be at least an angled line and crosses the y-intercept. So I'm going to write y equals, and now I need, again, the slope. The slope for this line, I'm going to go down in more of an open space here. It looks like it goes down 2 and right 1. Since that is down 2, I'm going to put a negative on that. Okay, so I have -2 over 1, which equals the same as -2. So there's my slope for that line. So I'm going up here and writing -2 x. Okay, but let's not forget the y-intercept, so I need to see that that crosses y at the same spot as line K does, so I'm also putting plus 4 there. Okay, lines R and P are interesting cases because they're straight up and down and straight horizontal. You have a couple spots in these lessons that covered that, okay? That does not fix the y equals mx plus b scenario. First off, because the slope is not normal, and also because it doesn't cross, it doesn't really have a normal y-intercept, okay? So there was a practice problem specifically on this as well that showed 4 straight lines. 2 of them are straight up and down, 2 of them are straight horizontal. So if you're doing your practice problems, you know what to do here. Okay? So for line R, it goes straight up and down and hits x at 1. Okay? So anywhere I go on this line, it is touching only one spot, one number on this graph in any way, and that is 1. Okay, so the line for this graph is x equals 1. Okay, and that's it. It is just a straight up and down line where x is 1 and anywhere I look, x is 1. Okay, x is 1, x is 1, x is 1 here, x is 1 there, it's x is 1. Okay, P then, since it goes horizontal, the only axis it hits is y. So where it hits y is -6. And y equals -6 is true anywhere I look. Right here, y equals -6. Right here, y equals -6. Anywhere on that line, y equals -6. So that is my equation for that. So those two are not entirely normal. They don't fit the y equals mx plus b. But this unit did have us practice horizontal and vertical lines. So if you paid attention to that, you are good to go. Okay. Number 5. Noah is growing 3 types of trees. He is keeping track of the height of each tree over time. This equation represents the height of the first tree. So tree 1, okay, going off on the side. Tree 1 is an equation. H equals 3.5 m. I'm assuming m meaning months and h meaning height, right? We should assume that. Okay, the second tree is in this table, and the third tree is in this graph. Okay, the thing is, this equation here is fitting my y equals kx format, where k is the constant. And we also know that the constant is a unit rate. Okay, this is, again, that little bit of 7th grade review. So if that's the case, then this 3.5 actually stands for 3.5 feet, since it says that in height per month, right? So 3.5 feet per 1 month. Okay, so there's its actual speed is in the equation. That's its constant. So I have to look here. I have months and feet. Can I turn that into a unit rate? So you have a couple ways to do that. I can go ahead and make a ratio to say that this is going 5 feet per 2 months and try to turn that into 1 month. Okay? If it's 5 feet in 2 months, then actually divide that, and I get 2.5 feet per 1 month. So number 2 is 2.5 feet per month. Okay. I also could see that that is my horizontal constant, right? Times 2.5 equals 5. 4 times 2.5 equals 10, and so on. Okay, that is my K constant. That's my unit rate. Okay. For number 3 then, as we transition from 7th grade to 8th grade, we see that that constant should be the same as slope. Okay. So an issue here though, if we just look at slope, and you guys want to grid count on this, it looks like it goes up 1 and right 1. Oh boy, light went out, hold on. Okay, but unfortunately this is, that would look like 1 foot per 1 month, okay? But I'm here to tell you that that is not correct. Let's look closely at the numbers here. As this goes up 1 box, that is 4 to 6, which is actually 2 feet. Okay, so that's 2 feet, and right to left, that is 1 month. Okay, so number 3, if I go back over here, is growing 2 feet per month. Okay. Number 1 is 3.5 feet per month. Number 2, 2.5 feet per month. Number 3, 2 feet per month. So the correct answer here is tree number 3 is growing the slowest. Okay? And I would explain that I was able to compare the rates and I would probably say then, like, to explain deeper, 3.5 is the unit rate in the equation h equals 3.5 meters. 2.5 feet is the unit rate in the table, and on the graph I have 2 feet per month is the slope of the line. Okay, that we can compare all of those things in one way or another. The slope, the unit rate, and the constant K are the same thing. Okay, or they're the same thing in a math equation.